It is Wednesday and I am going to record our video on 9-2, and 9-2 is going to be adding and subtracting the rationals. The previous section, 9-1, was simplifying them and multiplication and division. So today we're going to look at addition and subtraction. So the first few problems here, I just have some, kind of review stuff on what we just did. I'm going to go through them pretty quickly. So, you guys can pause and try them on your own first, just to make sure, you're adept to what it is. But, excuse me, I'm just going to go through these rather quickly just to review what you should know. For the first one here, first thing I would do is just try to factor out everything I can. So I have 14, I have 21, I know 7 with both of those. I have 3, 2. C, the C squared. This day, 22 becomes 11. 2. So when I multiply, just for simplicity, I'm not going to rewrite it. So hopefully you guys can make it out. I have a -4 top when I multiply, and then I have a B and a C left. So B's. On the bottom, I have 33. So this would be my final answer. I can't eliminate anything else. For B, for this type of problem, first thing I want to do is rewrite it because I can't have division. So I'm gonna factor it too at the same time, just so I won't have to rewrite it more than once. So it's gonna be x minus y, x plus y. This is a difference of squares, even though it's both variables, it's still the same process as you would do it with a number. And then we have a 36 y squared up here, and x plus y on the bottom. Again, when it's division, you change it to multiplying by the reciprocal. All right, so that's going to allow us to, again, I'm just kind of going through these quickly, us to eliminate these two. We can eliminate the y squared and the y at the bottom, and we can eliminate the 6 and the 36. This becomes 1, and this becomes 6. So when we go through and multiply, we would end up with the whole 36 is out. So it'll be 6y times x minus y. And then this is a 1. Again, you want to make sure you put it there so you do know that it's not like a 0 in the denominator. And because it's just 1 in the denominator, you don't need a denominator at all. You can just write it as 6y times x minus y. For the next one, number C, again, I'm going to just go through it quickly. Hopefully you guys are pretty okay with factoring something of this caliber. And then on the bottom, we have I have x's. I tend to do that. I'm just going to stick with x's so I don't have to rewrite everything. X plus 2. And then for this one, sorry, mine was too long. We're going to change it to multiplication. And because it's a -4 and a -12, it's going to be x minus 6 and x plus 2. Whatever, wrote it wrong, but same thing. And then over here we have, again, I keep switching. I'm just going to stick with my x minus 4. So these are gone. Again, this now becomes a 1. These are gone. This now becomes a 1. So I end up with x plus 3 times x minus 6. And again, since the denominator is just 1, I can leave it alone. I have a few fraction review problems here. Again, it's obviously you guys can just punch a fraction in the calculator for addition and subtraction, but I just want to go through the process so you're comfortable with it, because So when it comes to addition and subtraction, the thing we do need is a common denominator. So that's the first thing we should focus on. Minus. All right. So our common denominator for 3 and 5 is going to be, we can just multiply at all times to get it. So 15 here. That's a minus. That's pretty big. In order to get the bottom to the top, so it's times, on top we get 6. Here we're doing times 5. So times 5 to the top we get 5. The denominator, and you just subtract the top. So it's going to be 115 for the first one. For this one, 28 plus 28, that's our common denominator. We're doing times 4. Here we're doing times 7. So we'll end up with, sorry, I didn't write 4. It's going to be 16 plus 21. Answer is going to be 37 over 28. And you can leave a fraction improper after, middle school. Really don't worry about you guys doing mixed numbers. So you can just leave it like that. And then for the last one, F, there's going to be one or two like this today. So I just want to make sure everyone's clear on how to do it. So this is a complex fraction. So it basically means you have this, and then you're dividing it by this. So you have 3/4 minus 1/3. 3/4 minus 1/3, and then you're dividing that by, I'm just going to put it in parentheses, 1/2 plus 1/5. So what I'm going to do is just ignore this whole thing for right now, do the subtraction, do the addition, and then I'll come back and do the division. So over here, our common denominator will be 12, and we get 9, and here we get 4. So when we subtract that, we end up with 5/9. Then over here, because this was subtraction, then over here we have common denominator is 10, not a 1. Common denominator is 10. So here we go. And then we're going to end up with 5/10 and 2/10. So over here, we'll end up with an answer of 7/10. So then once we get this down, this is our answer for the top. This is our answer for the bottom. So we still need to divide those. So then comes your knowledge of division, which means you multiply by the reciprocal. And once you multiply by the reciprocal, it's just tops and bottoms. So our answer is going to be 50 over 63. All right, so let's get to the new stuff. So for today, again, we're going to be adding and subtracting these rationals. And these are the steps that we're going to follow. First thing we're going to do is just like the multiplication and division, the first thing we want to do is completely factor everything that we can. That'll make our lives much easier. And then the second thing, again, if we look at the two we just reviewed, when it comes to addition and subtraction, we need a common denominator. So that's what we're going to have to focus on, is finding a common denominator. The common denominator is going to be the least common multiple. I know you guys have heard of this in the past. The LCM of the denominators. And then we're going to follow up after we find out LCM. Excuse me. We're going to either add or subtract the numerators, just like we did here. We got the least common denominator, multiple, and then we subtract the tops once we get the answers. Here we add the tops. All right, so let's apply these rules. So here's the first couple of examples. The first couple of examples, I'll probably do the first two, leave you guys to do, I'll do an add and a subtract. Leave you guys to try the other one on your own, then I'll just put up that answer. All right, so the first thing we need is a common denominator. So if we're trying to add these, we can't, because again, they're not both 2x cubes at this point, so we cannot add them. Now, we can just always, as a fail-safe, just straight multiply the two bottom numbers. Now, the issue here, first of all, this one has nothing to factor because they're just monomials. It's just one single term, so it's nothing to factor. So basically, it's already factored. But the thing we want to do is we want to have that LCM, so that least common multiple. Again, can we just multiply and say 16 x to the 4th, y to the 3rd? Yes, but that's not always the best common multiple, so you want to approach it a little bit differently, and I'll explain. Okay, so if we just went ahead and multiplied it, this number is bigger than we need it to be. Now, again, does that mean that what we're going to get is wrong? No, it just means that we're going to have to end up reducing that answer more, and you want to try to avoid that. And again, the kind of connection to that is, let's say we had numbers like 5 and 8. We can just go all the way to 40 as being the least common as being a common multiple, but we don't necessarily, do we have to go that high? I'm thinking, yeah, actually we do have to go that actually we do have to go that high for that one, so that's not a good example. But let's say, let me pick a better example here. Erase that. Let's say we had 2 and 8. And I said we can just multiply them and get we can get a multiple of 16. Now, Is it wrong? No, we can actually add them with that denominator of 16. But if we had a smaller common denominator, we could have had, I'm sorry, least common multiple, we could have just got this to become 8. And that meant we would have just had to multiply this fraction by 4 instead of multiplying both fractions, etc. So that's kind of this idea of the least common multiple. If we find a smaller number, it might make our lives work out a little easier instead of going for this just multiplying the denominators. So let me explain what the least common multiple would be for this one. For this particular example, if we look at the numbers 2 and 8, 2 can multiply to become 8. So we don't need to multiply those. So I'm going to right now focus on that multiplying by 4. Then I need this to be the same for the x's. So in order for these to be the same, it would have to be x cubed. That's the only way to get them to be the same. So that would be an x cubed. And then I need a y squared. So my least common multiple is going to be, again, if I can find a common multiple, the smallest common multiple for the two numbers. And then pretty much we're going to go with the highest exponent. So we need 2, and the 3 here, we need the 2. When we are multiplying, to get 2 to become 8x cubed y squared, we have to multiply by 2y squared. That means the top also gets multiplied by 4y squared. On this side, we already have the 8. We already have the y squared. The issue is we don't have the x cubed. So in order to get this to be, we have to multiply this by x squared. We're going to end up with 12 y to the third over, again, this is our now common denominator, 8x to the third y squared plus 5x squared z over 8x cubed y squared. Again, so hopefully the next one will make a little bit more sense if this is tricky to you. So once we have a common denominator, excuse me, we don't do anything with that. That just stays. So that'll be 8x cubed y squared. And then we just add our numerators. These cannot be added, actually to say 17. They still can be added. So we'll just have to put it as 5. Actually, I guess I should leave the y. We normally put it in standard because the y is cubed. It has a higher power than that too. So we put that first. So 12y cubed plus 5x squared would be our final answer for this problem. It looks a little crazy, but that would be it. All right, let's look at the second problem. For the second problem here, I said I was going to do the third one, but whatever. For this problem, it's addition again. So first thing we need is a common denominator. If we look, we have 5 and we have 10. So I can get 5 to become 10, so I don't have to go for 50. So my least common multiple is going to be keeping the 10. How do I get 5 to become 10? I multiply by 2. So I know that's going to be what I multiply by. Again, I'm going to have to go for the highest power for any exponents in the denominator. So we have an a cubed, we have an a, so we're going to have to go with a cubed. We have a b squared, we have a b, so we're going to go with b squared. So this is our least common multiple, the lowest we can go. So this denominator is going to have to be multiplied. Multiplied by 2. We already have the a cubed, so that's checked. We already have the b squared, so that's checked. We don't need to do that. We only need to multiply by 2. So top and bottom get multiplied by 2 and move it over. Delete all that space. So this is going to end up being 8 over 10 a cubed b squared plus this side 10, check. We already got that. We don't have the a squared, so we're going to have, a cubed, so we're going to have to multiply by a squared. we don't have a b squared, so we're going to have to multiply by b. So times a squared b at the top. So it's going to be 9a squared bc over 10a cubed b squared. And then we actually add those up. So at the top, we'll end up with 9a squared bc over 10a cubed b squared. All right, and I'll just go ahead and do the last one. It's not going to save me too much time anyway. And for that one, excuse me, I have 5 and I have 16. Can't go, I don't think I can go any lower than 80. Let me think. Yeah, can't go any lower than 80 because 16 times 5 is 80. So I have to go for the 80. Again, I have to go for the highest power for any of these variables. So I'm going to have to go a cubed and I'm going to have to go b squared. Now, 16 times 5 is how I get 80. So this is going to be times 5. I already have the b squared, so I need an a cubed here. So I'm going to multiply by a cubed. Same to the top. On this side, I'm multiplying by 16 to get 80. Already have the a cubed checked. I need a b squared. This is just b, so I'm going to have to multiply by b. So my answers are going to be 15a to the 5th over 80 a cubed b squared minus 8 times 16, I have no idea, I'll get my calculator. 8 times 16 is 128, so 128 bx over 80 a cubed b squared. And then the last step would be to do the actual subtraction, so it'll be 15a to the 5th minus 128 bx over 80 a cubed b squared. Annoying, but that's how you do it. All right, so now that we've done the kind of monomial type of problems, let's look at the ones that'll be more polynomial type where you have to add and subtract them. So the first thing you want to do, now this is where step 1 will really take place, is where you have to factor it. So let's start off by factoring completely everything. So up top we have a 5. Do anything with that. Here we can factor out a 6, so it'll be 6x minus 3 minus x minus 1. And then our denominator here, we can take out a 2 first. So if we take out a 2 first, it would be this, 2x squared minus 7x plus 3. All right, and then at that point, again, unfortunately, I shouldn't have probably started you guys with one that has the AC factoring, but it does. So this one has the AC because it's a 2 here in the front. So it'll be AC equals 6. So you need factors of 6. That'll give you negative 7. It'll have to be negative 6 and negative 1. Again, this is the trickier one where you have to divide by a. And in this case, when you divide by a, you'll end up with 2, which is our answer. This will be 2x minus 1, and this will be x minus 3. Now, let's look at our common. Now we have to look for our common denominator. So to be honest, these are a little easier to me than doing the monomials because it's a little clearer like what you have to multiply by to get a common denominator. So, or at least common multiple / common denominator. So for this first problem here, we have an x minus 3 in this denominator already. We have an x minus 3 in this one. So check on that. We have a 6 here, we have a 2 here. So the LCM between 2 and 6 is going to be, I'm just going to write it over here. So our LCM is going to be 6. We already have the x minus 3. And then the other thing that's going to be needed in both things here is going to be the 2x minus 1. So this is our least common multiple, aka our common denominator. So let's rewrite it. It's going to be 6x minus 3 times 2x minus 1. So basically what I multiplied by over here was the 2x minus 1. The top times 2x minus 1. I can just leave it like that for now. Minus 6x minus 3, 2x minus 1. So for this one, I already have the x minus 3. I already have the 2x minus 1. The only issue is that this is not a 6. So how do I get 2 to become 6? I multiply by 3. So I'm going to do times 3, top and bottom. And I'll end up with 3x minus 1. Now at this point, I'll let you guys leave it factored, but you'll see sometimes the answers will be multiplied out. So just want you to see how I would do it, but I'm fine with it saying like this for an answer. So for all intents and purposes, it's your answer. But again, sometimes it might be multiplied out. And by multiplied out, it just means that I could distribute this and have it as a 10x minus 5, negative 3x plus 3. And then my answer would be 7x minus 2 over 6 times x minus 3. So just be comfortable, knowing, sometimes you might have to keep going with it and sometimes you can stop depending on the problem. All right, so let's move on to example 4, I guess this is. First thing we want to do is factor everything we can. So for this one, again, we have our x minus 5 over x minus 3, x plus 2, minus 4 over 5x plus 2. All right, so now let's get to our LCM, find our common multiple. All right, so for these, both denominators already have the x plus 2, check. And this one has a 5, this one does not. So our LCM is going to include a 5. It's going to include the x plus 2, because there's no way to get rid of that 5. And it's also got to include this here, our x minus 3. So this is the LCM that we're shooting for. So I'm going to write this down. This is my denominator now. 5 times x plus 2 times x minus 3 minus 5 x plus 2 times x minus 3. So I look at my first one here. I already have the x minus 3. I already have the x plus 2. What's missing is the 5. So that means I have to multiply by 5 up top. So it's going to be 5 times x minus 5. On this side, I have the 5. I have the x plus 2. What's missing is the x minus 3. So I'm going to do times x minus 3. So it's 4 times x minus 3 up top. Again, I'm just going to finish them out. You can sometimes leave it factored. Sometimes I'll want it out. So it'll be 5x minus 25. Again, I'm distributing here. And this is a minus. So it's minus 4. So when you distribute that, it's going to be negative 4x plus 12 over yada yada. I don't feel like writing it all yet because I don't want to write it twice. So I'm just going to do all the simplifying at the top. Going to end up with x minus 13 over 5 x plus 2 x minus 3. All right, next example. For this one, I'm gonna give it a try. I'm gonna pause the video and just go ahead and put most of the answer and see if you guys can catch up to me at the end here. Okay, so for this next one, once I get it factored out, unfortunately, I don't have anything in common between the two elements in either denominator. So because of that, that means that over here I have to multiply by 3 and the 4x plus 1. And over here I have to multiply, that means up top I have to do the same thing. And then over here I have to multiply by x plus 5 and what's the other thing? 4, oh, they are the same. I'm sorry, for some reason I didn't, I thought this was scribbled out. I thought I just had an x plus 1 here. Oops, sorry. So that makes my life much easier. Praise God. So since it has the 4x plus 1 already, I don't need to multiply by that. It'll just be multiplying by 3. Whoops, it is much easier. Oh, erase. All right, there we go. So this is just going to be times 3. This is going to be times 3 because I just need a 3 over here. So they both have a 3. They both already have the 4x plus 1. So on this side, I just need to multiply by the, where is it? X plus 5. Squeeze it down here. And I'm multiplying on the top by x plus 5 as well. All right, so over here I'll have 3x minus 8 over 3x plus 5, 4x plus 1, plus 6 times x plus 5 over 3, x plus 5, 4x plus 1. All right, again, I can distribute at the top and simplify. Again, a lot of the times for these type of problems, it will ask you for that. So it'll be 3x minus 24 plus, it's a plus now, so 6 times x is 6x plus 30. Answer is going to be 9x plus 6 over and you could go further, but I wouldn't. That's fine. I don't feel like simplifying it further than that. But technically you could factor out a 3 from this and keep going, but I'm good. All right, so let's move on to the next problem. For the next problems, that's another one that has just a bunch of monomials. Pause the video and give that one a try on your own. Okay, so once you have your LCM, then you just add it up and what your answer is going to be. All right. Okay, so for the next one, this one is subtraction with the with the rationals and polynomials. So let's start off by factoring this one. The top can't do anything with. Bottom, we can take out a 3. Here is x minus 5. The top, we can take out a 3 again. This time it's x plus 5. And then the bottom, again, we can take out a 6 this time. It's going to be x minus 5. All right, so once we're completely factored, sorry about that. Once we're completely factored, we look at our denominators. They have to be the same in order to add them. So they're not the same, so we can't add these right now. So it's a pretty easy fix. We just need this to be the same, the 6 and the 3, because we already have the sames with the x minus 5. So how do I get 3 to become 6? I can just multiply this by 2 on this side. But again, remember top and bottom. So over here, it stays 3x plus 5 and 6x minus 5. The bottom over here is 6x minus 5 as well. So common denominator, check, we're good. And then on the top, again, multiplication. So this has to be distributed, and it's not just the only, like the first term. So I'm just going to write it as 2x plus 10. Again, I'm going to finish it up because I tend to simplify with these types. So it's going to be 2x plus 20 minus, I'm going to distribute here too. Again, I'm going to put minus negative 3. So it's going to be negative 3x. 3 times that, it's negative 15. I simplify all of that, I get negative x plus 5 over 6 times x minus 5. And at this point, you could stop and just call it a day. If you wanted to, you could go further. Might remember when we have opposites here that we can make this a negative 1. So the answer for this would technically be 1/6. But I would have accepted it at that point as well. All right. I'll probably pick one from the book a little later to do. I feel like I should have probably done another one or two with some more factoring. But so that's that. Let's look at one of these complex ones. I'm probably only going to give you guys one of these, if that. I'm not going to go like crazy heavy with it. But I do want you to see the process and how to do it. But on the quiz or something, I'll probably only give you one. And again, we do have a quiz next Tuesday, not Friday this week. So let's get going. So for this one, first thing you want to do is make sure you decipher the problem. This whole thing means it's this divided by this. So I'm going to rewrite that. So it's C over D minus D over C. And we're dividing it by D over C plus 2. All right, so now I'm going to go ahead and do this, and then the last thing I'll do is try to bring these two parts together. So for this first part over here, again, I need a common denominator. So right now I don't have one. The common denominator is going to be D. All right, so I'm multiplying by D, I'm multiplying by C. So I have C squared, I have D squared. Top I end up with C squared minus D squared over DC. Then the other side of the problem, let's do a different color for that. For this one, let's use orange. So I have D over C plus 2 over 1. Again, anything I can immediately make a fraction by putting it over 1. So now I need a common denominator. That common denominator would be C. I have C here, so nothing to do. But over here, I need to multiply by C. So it's going to be D over C plus 2C over C. I end up with D plus 2C over C. So I have this divided by this. So now I'm going to rewrite it. The first one stays the same. And I multiply now instead of dividing by C over D plus 2C. Now I'm going to try to factor it. It's probably for naught because I'm pretty sure nothing will factor out here, but we can get rid of the C's as well. And yeah, I mean, I can tell nothing's going to happen, but if I did factor this, it would be C plus D, and it will be C minus D. So if I look here and on that diagonal, nothing will cross out, so nothing will benefit me in doing that, but I'll still leave it factored. C plus D, sorry, and C minus D. Again, I don't need the times 1 because it won't change anything. And then on the bottom, I have D times D plus 2C. This would be my final answer. All right, so give the second one a try, and then you can look at my answer in a second. Okay, so here's the final answer for the last complex fraction. In hindsight, I'm just going to post the rest of the answers because I'm already at 30 minutes, so I don't want to take another 5 minutes to do another one. So if you look here, you know, in what's posted, there's some practice problems in the textbook. Give all of those a try and etc. Hopefully this was enough to get you through the adding and subtracting of the rationals. Again, you're going to have an exit card on Friday at 1:30. That's our new posting time. And our quiz will be on Tuesday.